Coming up on today's show, gate placement, gate location, injection speed, pressure, and profile are all variables you can leverage for optimal part performance. And welcome to the show. I'm your host, Kurt Stahle, that plastics guy. If this is your first time listening, well, thank you. And this is where I share my almost 4 decades of plastics industry experience with you. Today I'm on my own, but sometimes I'll have a guest or two. I'll educate, share stories, showcase innovative products, and always discuss the topics and trends that affect our industry. Today's podcast is sponsored by Poly 10 in Woodbridge, Ontario, compounders of colorant, processing additives, and functional master batches, and by my company, Simcoe Plastics Limited, where we have a passion for polymers. Please visit us at simcoeplastics.com, or you can contact us through info@simcoeplastics.com. So for today's long format podcast, I wanted to do something a little bit different. Not an awful lot of script, but I'm sharing a case study with you. And it's something that I got involved with going to a customer when they called me earlier in the week to talk about some really interesting processing issues they were having on one of their components. I'm not going to name the name of the customer or the component specifically, but we'll talk about some of the gate details and what we did in terms of colorant. So the main issue was what looked like a color streaking problem. And there can be a number of reasons why there's color streaking. Now, this is in no particular order, but you can have issues where there's a combination of pigments in your colorant, and one or more of those pigments are operating beyond their temperature threshold. And we typically see this more so when we're dealing with nylon or other engineered resin components, where we could have a certain type of red or a yellow, and nylon operating, typically in that 500 Fahrenheit or even more range, especially if you're dealing with hot runners or injecting under a very quick speed, quick cycle time, the pigments simply won't survive in that type of environment. So they can color shift, and essentially they're burning. So they'll color shift, cause streaks, and we can't seem to figure out what's going on until we actually look at the formulation and identify, okay, that particular pigment, well, that's really more for a polyolefin or a styrenic application, and we have to exchange that with the closest equivalent we're going to get to operate at the temperature of an engineered resin, which probably is going to force a change in the rest of the color formulation so we can get the color back on track. So that's one cause of a color formulation. A color streak. Another issue, and I think this is really more of what was playing with this particular issue the customer was experiencing, it's gate design. Now, this particular component went through a couple of different changes where the gating was actually happening, and there were reasons for that, which I just out of courtesy for this particular customer and their application, I'm not going to divulge anything, but they had to move the gate. And in doing so, the gate was moved, and it really wasn't done in such a way that the gate land, where it connects to the part, was uniform. So what's happening under injection, you're creating a situation where you've got plastic coming into the cavity of the mold, and it's coming in under 2 different velocities or pressure, if you will, because you've got a thicker section and you've got a thinner section. So you're immediately going to create a jetting phenomenon, and the plastic is going to fill in an uneven, non-uniform manner. Now, if you're dealing with a situation where maybe it's just a black part and you're dealing with nothing more than carbon black suspended in a color concentrate, well, that's probably not going to cause an issue. Carbon black is very forgiving. Other colors, not so much. And the color we were having a problem with was a light gray. So why would that be a challenge, considering there's probably some carbon black in there to have it go gray? It's more than likely the combination of some degree of pigmentation and titanium dioxide, TiO2. Typically, there's a fair amount of loading of TiO2 to make a light color. And under certain conditions, that change or that differential in velocity coming through a gate can actually cause a situation where the pigment can sort of get knocked out of the polymer matrix. It's rare. It happens. I've seen it a few times in my career, but it can happen. So if you're diagnosing a color streaking issue, you definitely want to look at the runner system of the part. Make sure that everything is uniform. If you can accommodate as many gentle radiuses as possible. You know, one thing I brought up to the process tech that I was working with on this particular application, not too many people mold flexible PVC anymore because from a material standpoint, it's kind of gone out of fashion and replaced with TPVs and TPEs, you know, polyolefin-based materials, which are not particularly shear sensitive. But if you go back to the days of flexible PVC, they were incredibly shear sensitive. So we had to go out of our way to make fully round runners and gentle curves and lots of cold slugs and nothing that would cause shear because that would burn the PVC. So now that we're sort of out of that flexible PVC era for the majority of things, I mean, yes, there could still be some automotive exterior trim done in PVC. It has its applications. I think it's great for so many things, but the majority of things that we interact with every day, it's gone. So we're sort of out of that mindset of how to design a very forgiving runner system, gate, land, all of that good stuff. So in this particular application, the gate wasn't quite the way it should be. And there were two different lands on this part coming off of a common runner system. So we adjusted one of them first, and we got the results we wanted, where some of what we call maybe, or someone might look at it and say it's flow lines or it's a color dispersion issue. Well, it was really a jetting problem from an uneven injection pressure across this land in the gate. So we corrected one, we got rid of problems there, and we were actually able, through some processing, which I'll get into, to make these color streaks disappear. So I thought, hey, great, job done. We're going to wrap it up. We'll get the quality manager to sign off on it. We may have to do a little color tweak yet to get that final approval, but here we are. We're essentially job done for the day. And then, nope, we're not done. We had another flow line, which I erroneously thought was a weld line. So we did a couple of short shots, and it was clearly demonstrated that wasn't the weld line, but it was a very significant flow line. So I looked at the land of that gate and I said, well, we really have to open that up to get a uniform thickness. So fortunately, that adjustment was done, and done, much to the customer's credit, very, very quickly with the mold clamped into the machine. They sent over a mold technician, got it done, did a really great job. So now we had both lands on this particular part as uniform as we're going to get, no velocity differential, and we fire it up, and it takes a couple of shots for the machine to settle down, as we all know. And sure enough, that particular weld line, I'm calling it a weld line, a flow line, had pretty much been minimized, not eliminated due to the actual location of the gate or land relative to the part, but it looks much, much better. But guess what? We had color streaking issues back again. And this made no sense because we had pretty much dialed it out. And we found by adjusting the back pressure, if we put a lot of back pressure on the machine setting, we could actually induce these color streaks. So we had backed down the back pressure and gotten rid of the color streaks prior to opening up the second gate. So it's like, well, wait a minute, what are we doing now? So the next thing that we focused on to try and come back to this ideal setting was to focus on not just the injection speed, but the pressure. So yes, you can actually have different speeds, different profiles, and simultaneously change the pressure. I mean, if you work with injection molding machines every day, I'm not telling you anything different, but I think it's really key to remember that you can move the screw during injection at a different speed and with pressure behind it. And I guess, I look at it and think, well, this is like horsepower and torque. And if you're a car person, you understand what I'm talking about. Horsepower is like the speed of the screw, if you will, and the torque is the force behind it. So we could still apply a lot of speed to the injection, but we don't necessarily have to give it the same level of pressure behind that speed. So we backed off the pressure somewhat, and we actually got a little bit better of a result. So I thought, well, this is great. Now let's look at the profile and trying to understand what we were doing to optimize the profile. What we had found when we actually come in at a slower speed, there were 5 particular spots, V1 through V5, 1 at the throat of the machine and 5 closer to the nozzle. We have to start off quickly, and if we changed the speed, if we slowed it down for, say, V3 through 5, we actually got a worse looking part. We got color streaking and just overall some more flow lines. So I thought, well, this is interesting. This particular part, the way it's set up, it likes a quick injection profile, not a reverse profile, pretty standard. Give it a lot of speed right from the get-go, but we were able to determine where we could taper it off. But we had to taper it off in a consistent manner, V3 through 5 at a consistent speed, but tapered off compared to V1. So once we did that, we actually got the process back under control, which I was really delighted to see. And, by this time, the workday was done, and we had pretty much stood around a machine long enough. We couldn't take it anymore, and I hate to say it, but at my age, standing on a shop floor all day is not kind on my knees or my feet. So I was quite happy to call it a day, and so was the process tech I was working with. But the main thing is, we actually got to a point where we could make a part without streaks. So what are the takeaways? We can alter color. I'm not going to say dispersion because this is not technically a dispersion issue. This is trying to keep all the pigments within the polymer matrix. So it's a little bit different than a dispersion issue. We're trying to reduce severe changes in the velocity of injection speed and pressure through the gate. We want to create something that's uniform. We want to try and get that plastic into the cavity of the tool without too much, we'll call it trauma, I guess. And I think, that's kind of an appropriate thing when you look at this color streaking with the pigment actually sort of coming out of the concentrate itself and breaking away from the polymer matrix. So that's causing a lot of shear, a lot of trauma if it's not injected right. So we have to create something very smooth to get that colorant in there without streaking and still having to fill the part, minimize the flow lines, and park the final weld line in a spot that is non-visible, and for this particular part in a safe an area that won't interfere with the functionality of the part. Now, the interesting thing is my colorant supplier spent a lot of time working on this, developing a formula, doing some interesting things, and I can't divulge all of our trade secrets. And I think the upshot of this was we could defeat some of those characteristics of this formula by how we processed it. And I think that's a great takeaway. You could try and optimize all of the chemistry, but if your machine settings aren't quite where they need to be, you can really defeat an optimized product. And I'll repeat that again. If your machine settings are not optimized for your process, you can defeat an optimized product, whether it be the base resin or the colorant. So what did we learn? Well, we learned that we had to, in this particular application, inject with a uniform speed. Faster was better than slower. And I've seen this with other materials that I guess you could say it's a little counterintuitive, because you would expect, if you're experiencing a color streak, you may want to take a more conservative, lower speed, lower pressure approach. But this particular part had a lot of design features, and we felt going slower was causing turbulence over those design features, and that was contributing potentially to the color streaking that we saw. So we took a faster injection speed, a little bit less pressure, but a faster speed, uniform speed, perhaps creating a situation where the resin and colorant was skinning up, covering the surface of the tool, and not getting caught in any of the design features and creating maybe some sort of vortice that was knocking the pigment around and causing the streak. So fast profile on this, uniform in 3 out of the 5 speed zones that we could regulate, not optimal or not maximum pressure. We backed it down to about 70% pressure. That was good. And not too much back pressure. It can be a very common move if you're having true dispersion issues with your color concentrate and base resin to increase back pressure to promote mixing. It's one of the first things that you do. What we saw in our situation, we added back pressure, we actually exacerbated the color streaking. So we had to turn it down. And I think that was important to see that we could actually process around that. So the next thing we learned was the gates. We had to make sure that the gates were uniform. And in my opinion, what this did was allow the process tech a wider processing envelope on this particular tool and machine to come up with the ideal process. So if you have a situation where the tool itself isn't optimal, in our case, we had an ununiform or not uniform land size or gate size coming into the part, we had to correct that. And that just gives a little bit more flexibility to the processing team, and they can develop an optimized process. So at the end of this, are we actually going to create an absolutely 100% perfect part in this particular light gray? I don't think we will, because there are some limitations of where the gate is placed and how it actually causes the plastic to flow, and we can't get away from that. The gate is where it is for some other reasons. We can't move it. So all we can do is create the best possible part with the pieces that we have. But we optimize the gate, we're optimizing the color concentrate, and we're working through a process. And this is sort of the art of compromise with engineering or processing and many things. You look at all the variables and what do you do to come up with the best possible compromise of a solution, because perfect is not attainable. In series production, yes, you might be able to create that part one-off that is absolutely perfect, but when you're running 40, 50, 60 parts an hour, you're not going to create 100% perfection 100% of the time. It doesn't work like that, and we understand that coming from manufacturing. But I think we got a really good result after a hard days of work. We're going to come back and do one more day there with a color tweaked product, which I think we'll get our final sign off, and then we'll carry forward and hopefully have series production on this and some other projects coming up with this particular customer. But it was a hard fought battle, and I think we're about 95% there. So I will keep you posted on what happened and share any other interesting tips and tricks that we might be able to, sort of pull apart from that particular case study. So that's really what I wanted to talk about on this particular episode of Processing for Optimal Appearance. We got a number of things that I hope you can take with you on the shop floor, and at least, think about when you've got those difficult situations. Make sure everything is just in line, especially, look at the tool, make sure you don't have any variables there that are going to hang you up, and, take it from there. So feel free, as always, to contact That Plastics Guy, that's me, on LinkedIn, and let me know what you think of the show. If you have any questions, please ask away. I really appreciate hearing from you. And maybe one of your questions will be the basis of an upcoming show. Please follow Simcoe Plastics on Facebook, Instagram, and YouTube, and subscribe to our newsletter through the website. I'm on LinkedIn at Kurt Stahle, myself personally. And by the time this episode airs, which should be Canadian Thanksgiving Monday, I'm doing it recording it a few days in advance, we'll have our October newsletter out and we'll have plenty to share with you. So in the meantime, thanks so much for listening. Take care and bye for now.